equal to 0. So the SDR is what? 4 pi r minus 86 over r squared. I want that to be equal to 0. Is there a question? Yep. Uh-oh. I said uh-oh. Yeah. I did say uh-oh. I stand by my uh-oh.
How did you go from s equals to s of r?
So here I'm using a functional notation. I mean s is a function of r. That's not multiplication by r. See, that's the problem with this notation, isn't it? No, you're fine. I mean, that's a completely legitimate question. My point is, now it's just a function of r. Excuse me. So here's your equation the critical radius has to solve. Can you solve that? Man, at the end of every calculus problem, there's an algebra problem waiting for you, isn't there? It's annoying. It's like algebra is a prerequisite for this course or something. I don't know. Stupid algebra. Let's see, 4 pi. Just kidding, we love algebra. Equals to 86 over r squared, which gives me r cubed, is 86 over 4 pi, which gives me r is the cube root of 86 over 4 pi. Don't expect me to calculate that in my head unless I've got some time. I don't have that much time here. And so that radius will minimize the amount of material needed. Now, how do I know it's the minimum, though? You might worry, how do you know that's a minimum? What can we do to convince ourselves it's a minimum? I mean, that's not the minimum. That's where the minimum is attained, right? I still have to take this and go put it back into this over here to find h, and that would give me the h and the r, right? You guys understand that? Okay, so why minimum? You could ask the same question in the last problem. How did I know that that was the maximum area? It's pretty easy over here to go back and see that a prime prime of x was what? Right, second derivative is negative over there. So we found a maximum for sure. Why minimum? Well, how about s prime prime? 4 pi plus what? 86 times 2 over r cubed. The point is, when you plug in, that's greater than 0 when you plug in the critical radius, right? Therefore, we're finding a minimum by the second derivative test. Did we talk about second derivative test? I think I talked about the second derivative test here. Did I? Well, if I haven't already, if you have a critical point and the second derivative is positive, you've got a minimum. If you have a critical point and the second derivative is negative, you got a maximum. Which makes sense if you think about concave up and concave down. So, well, I hope I've said enough for you guys to attack the homework. Next time we will dive straight into logarithms and exponentials. Yep. What's that? Oh, sure. So second derivative test. So if you have a point where the derivative is 0, if the second derivative is positive, it's a minimum. If the second derivative is negative, it's a maximum. If the second derivative is 0, try something else. then the second derivative test doesn't tell you. Thanks, folks.